Another piece of paper. So what might be an equation that looks like a one variable two-step for 7th grade? How about 2x minus 3 equals 7? How about that equation? We know we're going to have two steps because we have a step to take care of this number and we have a step to take care of that number. And that's what's a little different about 7th grade. So let's model this guy over here. 2, and then I'm going to have, now notice that really what we have is 2x plus negative 3 equals positive 7. Because when we do physical models, I don't know how to demonstrate without moving things, taking away 3. So I solved that by looking at my negatives. Oh wait, we haven't even talked about the other side of the tile yet. Back when we defined our tiles, sorry, there's that paper. Back when we defined our tiles, if you look at the back or the underside of all of these tiles, it's red. And so this is actually really nice now that we have document cameras instead of like the old days with the overhead projectors, because you couldn't flip things and get a different color. But now I can flip big blue over and get red, and the green bar gets flipped over to red, and the yellow one gets flipped over to red. And we say, I wonder what that means. Well, the red square is the opposite of the blue square. And we represent opposite with our negative sign. Now, the red bar is the opposite of the green bar, so that's negative x. And the opposite of the yellow one is negative 1, and we represent that with our red square. Now, you can write these on your tiles, but as we've been doing our modeling, a lot of times what we're going to want to do is just negative 1, negative x, and negative x squared. And so I just put a negative sign in the middle of the tile indicating that it's red when I do my pictorial model. Does that make sense? So let's jump back to our problem and see how we model it. So we have the 2x plus 3 negatives. There we go. Now we know what we're doing. We have our equal sign, and then we're going to need 7 ones on the other side. There we go. So our pictorial model will look something like this. 2 x bars, 3 negative 1s, so put the negative sign in the middle, an equal sign, and 7 positives. Ooh, my squares get rough after a while, don't they? All right, so this picture represents this physical model, represents this symbolic model. They should always be connected. Now, we're going to try to do that same thing again where we end up with 1x bar equals something, right? So I just want one of these, but I can't divide at this point. And we want our students to start figuring that out, that it's messy. So really the first thing we want to do is get our x's alone, and then we can do that division thing. So to get the x's alone, I need to get rid of those 3 negatives right there. If I want to get rid of those 3 negatives, I can't do that trick we had with the last one where I just took them off. Why is that? Why can't I just drag these 3 negatives off? Well, there's no negatives over here to take off as well. So this is a little bit of a nuance here. If I need to take something away that I don't have enough over here to take away, I've got to find a way to do this. And this is kind of a big leap for the kids, but you really want them to get to the idea, well, if I only had 3 negatives on this side, I could just pull these guys off together. But remember, we don't give 3 negatives to this side unless we do what to this side? That's right, we have to give 3 negatives to both sides. But does that help us at all? Not really. It helps us in some, but it doesn't really help us with this one. What do we really need to get rid of these 3? Well, this brings up the concept of, ready for it? 0 pair. 0 pairs. And that's the idea that when I have a number plus its opposite, the answer is 0, right? So if I have a positive 1 and a negative 1 together, that's 0. So if these two together are 0, then it doesn't matter. Again, that identity property. I can add these all day, and this doesn't change anything. So the way I'm going to go over here and get my negatives to subtract is, instead of adding 3 negatives, I'm going to add 3 zeros. You see what I've done? Here's a 0, here's a 0, and here's a 0, right? And now I have those 3 negatives I can pull out. Does that make sense? Let's go back to our note page and draw what we just did. We didn't do anything over here, but we added 3 0 pairs over here, because this is where we need our negatives to take away. Does that make sense? So these are all 0, haven't changed anything, have I? Now what I can do is I can take away 3 negatives from here and 3 negatives from here. All right. When I do that, I end up with 2 bars left over here. Oops, 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 oops. Let me take them away. There we go. 2 bars left over here, and then I have 2, 4, 6, 8, 10 ones over here. And I'm going to be a little bit of a cheater, and instead of drawing them all out twice, I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I counted them as I just divided them into 2 sets. And now we can see that each X is represented by 5 ones. Now let's connect that symbolically to what we did. When we wanted to subtract 3 from this side, take away those negative 3's, how did we do that? By understanding 0 pairs. So if I wanted to subtract 3 from here, I wanted to get rid of, okay, so this is going to be a trick, minus a negative 3. Really, what was I doing? I added 3, didn't I? Remember, if we take away 3 negatives, it's the same thing as adding 3, which gives me my 0. So I really ended up just adding 3 to this side as well. So I have 2x equals 10. I divided both sides into 2 separate groups, x equals 5, and I have my answer. How do you guys feel about that? Is that going to work for your students? Now I do have a question for you. There is another way we could have done this piece. Would you like me to demonstrate it to you? And perhaps that's going to lead us to a little bit easier transition than we had right here. So I'm going to go back again. If everyone will be patient, bear with me. And we have our 2x plus negative 3 equals 7. So let's go back and say that we have our 2 bars, our 3 negatives, equals, so again you can do that equation or you can do a line, and 7. Now that we know about 0 pairs, is there something we can add to both sides to get rid of those 3? Remember, anything that has its opposite added to it is 0. So if I add 3 ones, then I get 0 pairs. Right? So if I add 3 ones there, then all I have to do to balance it out is add 3 ones over here. Right? So I had 2x plus negative 3 equals 7. I added 3 ones, I added 3 ones, I added the opposite to get my 0 pair, and now I end up with 2x equals 10. And then I just divide both sides by 2, put them into 2 different groups, and my x is equal to 5. This might flow better into our symbolic representations, where we say to get something from here, we either use an undo, we add the opposite of our constant term. Whatever language you use, this model might match it better. Okay, are we ready for 8? All right.